I go by Syntaxy online, and yeah, this is really great to be here. I'm just going to warn you guys ahead of time. My talk relies quite heavily on my slides, so if you can't see my slides, you might not get anything out of this. And that's cool. Feel free to just ignore this. That's cool too. But if you're interested, you're going to want to have a vantage point for the slides. Okay, so the title of my talk, which I didn't have it on my first slide, which I probably should, is Mighty Messaging. So I'm going to talk a little bit about messaging, which last talk was a really good segue into where I'm going. So we're going to take things, the next step after PubSub. So some of the more popular projects I've been associated with, co-founder of Apache Cordova and XUI.js, and I'm currently working on the Harp platform, which is static site hosting on Dropbox. That's at harp.io. And I maintain the Node.js Dropbox library. There's Harp. Check it out if you get the chance. Okay, so this is pretty dark. We're gonna see how this goes. Okay. So we're in a very fortunate circumstance for the most part when it comes to our users connecting to our applications. Their request goes across the country or across the globe at the speed of light, and we're able to process things on our servers and send it back to them. And the entire time, things feel virtually instant. And this is very nice, right? But this isn't always the case. Sometimes you need to pass things back to a background worker. And this can have bad consequences to the user experience. So what I'm not going to be talking about is how you connect your client to your server. And so you could do that with a WebSocket or long polling. The Node community covers that aspect quite extensively, and thankfully, in large part due to Node, it is a pretty solved problem at this point. But what I am going to talk about is this other side. So when you got to hand a job off to a worker machine, how do you keep the user engaged? Because that's what this is all about, right? It's about keeping a good user experience. And I think for the last decade or so, it's been acceptable anytime we're not able to go to our server and back to the user in less than a second, we just background things and we say check back later, right? This has been okay. It's gotten to where we are, but I don't think that's no longer an acceptable user experience. So I'm going to talk about how you have these servers talk to each other in a way that you can offer the same user experience as if you didn't have to background anything at all. So the first thing, I'll just do a little quick overview on some messaging patterns, and this is Message Patterns 101, which is practically a direct ripoff from ZeroMQ's guide. So if you're, the next 5 slides are probably have the most value in them. So pay attention to this if you're not familiar with these. So let's say we have these 2 processes or 2 machines that want to talk to each other. Well, we can send a request off to a machine, and we can wait for a response. Pretty simple. This is very similar to HTTP. Without the headers, it's just message passing. And this is request reply. So let's say we have one machine that wants to dispatch work to several machines. And we want to round robin. So as we pass these messages through, we want to just hand them off to these different worker machines. And we can do something like that, and that is a push-pull. And PubSub looks something a little similar. We have one server, in this case, and it's publishing to multiple machines. But in this case, with every message that we broadcast, we broadcast to every worker machine or every other node that's listening or subscribed to that channel. So it's slightly different. And finally, sometimes we just need to proxy messages from one machine to another. And there's some specific reasons where we need to do that. And we simply call this a pair. So these are our building blocks to doing some really powerful things. And when you understand these 4 principles, and you know, it goes a little bit further than this, but these are the 4 basic ones, you can solve pretty complex problems with very simple, elegant solutions. You'd be surprised like how few lines of code this actually takes to do these things. So back to our situation, and you can't see it, but there's arrows connecting these. But anyways, we could simply have a push-pull, which would allow us to spin up these workers and dispatch jobs to these workers, and this solves the problem of backgrounding things, right? And this is what we often do, but what happens if we need to scale out the servers? Obviously, we're not going to just run one process on that end. So we've already got a bit of a problem that we need to solve if we were doing a push-pull. And that's this discovery problem. So here we have our server, and it's dispatching jobs to these worker machines. A message comes in, it hands them out, everything is great, but the workers are under load. So, no problem, we spin up another worker, and the message comes in, bam, it's helping out. And we can just keep spinning up workers. This is great, right? But we have a problem. What if we need a new dispatcher? Well, now, when a message comes in, it doesn't know where to pass the message to, because when these workers were spun up, they were spun up connecting to that dispatcher. So when a new dispatcher comes online, well, it can't receive any messages unless we were to restart these processes one by one. Now that can receive messages from that dispatcher, restart that process. Now that one can receive messages. So now it's listening to 2 dispatchers. And this works, but not for very long. And as soon as we need another dispatcher, it's like, oh, crap. Okay, I got to go back to my, who knows, maybe you've got 1,000 worker machines, right? So this isn't very viable. Not good. Okay, so the solution. Remember when I mentioned the pairing? Well, that's where this comes in handy. Because what this does is this allows us to have dispatchers that are completely unaware of the workers. So the workers are only aware of where it's connecting to get messages, to do jobs, and the dispatcher is only aware of where to send a job. And it is a centralized place. But when we have this pairing relationship, I'm just condensing this down to a little box here to represent that. But the end result is that these are completely unaware of what's doing the work, and the workers are completely unaware of where the jobs are coming from. And this is good. So this is much better. So we know that now that in order to get around this problem so that we can scale both sides, we need to stick a broker in here. So let's stick a broker in here with push-pull with the pairing. And now we're good, right? We can scale out our servers and our workers independently, which it most likely will. We might only need 2 servers, but we need like 20 workers, or vice versa, right? So this is good, but we got a new problem. The new problem is that this is now a one-way path, right? So a job comes in to a server, the server passes it to the broker, tells the broker passes it on to one of the workers, but then what happens after that? That's cool, but now we've lost the user. The user's no longer engaged, right? So that's the next problem we're going to solve. So this just illustrates that point again. So from the dispatcher, we're going into the queue. The message goes to the worker, and now that's it. It's a lost entity. So this is, I'm calling it the observability problem. Now the solution here would be then to have, when the worker gets a job, it's broadcasting through PubSub on how the progress is going. So this job might have an ID, right? And it's saying, hey, this ID is like at 10%, and here's how it's going. And this is great. This solves that problem. We can now keep the user engaged, which is great. So now we're adding a PubSub entity. And just to be clear, like, we're doing the same pairing relationship in our broker with the PubSub so that a worker knows where to broadcast the messages to on how the progress is going, but it's completely unaware of what's listening to those messages. And the server knows where to connect to receive status updates on a job, but it doesn't have any idea what's doing the work, and that's great. Let's see where we are. Actually, I have no idea what this slide's about to represent, so I'm figuring it out as we go. Okay, we have a new problem. Is everyone following so far? This is cool? All right. So the new problem we have is when a user goes away. So typically, when you pass a job off to a worker, you do have some state, you have some persistence somewhere to represent maybe not high fidelity, but that the job is received, that the job is complete, or if the job erred, that's the state that it's in, or why it erred. So one of the problems we have here is we have the mechanism to send a job off to a worker. And we have the mechanism to listen to find out how it's going. But like, what happens if like this job half finishes, or the user leaves the site before it's finished, or whatnot? Like, what's happening to this job? Like, we need some sort of state somewhere. And that usually is going to live in the server, right? So the server represents like your app server where your database is, and that's where like truth lies. And so when a worker picks up a job, we want the server to know that it's been picked up and that it's about to get done, or if it does complete, that it is finished. And so what's happening here is what's possible is that when a job gets received, the other side kind of disappears, and in this case, this is the end user, before the publish events come up. Because you could use the publish events to capture that, but we're not going to do that. We're just going to use the PubSub in order to inform the user of how the progress is going. So instead, what we're going to do is we're going to do a request reply. That was a messed up slide, sorry. We're going to do a request reply so that when a worker picks up a job, it's going to do a request reply through the broker, again, a pairing through the broker, so that the server knows that the job was picked up. And this way, if the user disappears midway through an event and comes back, they're going to see their job is done because everything finished, because it's not relying on the user to be connected in order for that job to finish, because the worker is going to communicate independently with a request reply. And of course, we can use request reply in this case because these are transactions that are very inexpensive. It's basically like flip this bit in the database saying like, I picked up this job, or hey, things didn't go well, here's the error, or whatnot. Like, these aren't expensive operations, right? So what we now have is we have the broker that essentially has these three pipes that are proxying PubSub, a push-pull, and a request reply. And again, the whole point of the broker is to centralize where these two endpoints connect, and so that they don't need to have any knowledge of each other, so that we can still scale out the servers as well as the workers independently. So let's look at what a life cycle of a job looks like. So let's pretend we're the broker in this case, and we're looking at the messages that are coming through. Excuse me. So on the top would be the dispatcher. So the message coming from the dispatcher, and the bottom is represents the workers. So the first thing that's going to happen is that it's going to proxy this push-pull through. Not sure if you can read that very well. It says push there at the top, pull at the bottom. And it's just handing the job off to a worker. When the worker receives a job, it's going to reply back, say, hey, I've got this job, I'm working on it. And then it's going to start emitting events. When the user, from the client's perspective, when it sends the job in, it's going to connect to the pub sub to listen to the events. And this is how we can give the user a nice progress bar and whatnot. So these pub sub events are just going to keep going until the job is finished. And it can, like, we can be as descriptive as we want. It could be like the total payload size, how many bytes we need to move. It can be very specific. And then finally, when the job is either finished or it aired or whatnot, we're going to do another request reply. And then once it's all finished, we do one more broadcast saying, hey, it's done. So anything that's listening to see how things are going, we're finished. I've already updated the state with the request reply, so just go ahead and check the database if you need to, but we're all done now. So we've kept the user engaged the whole time. We've done something expensive, and this is good, right? This is the whole point, is to keep that user happy, keep them engaged. And you know, it's okay if they want to go off and like get a cup of coffee while things are happening, but that should be a choice that the user has. It shouldn't be something that we're imposing on them, right? So if they want to sit there and watch the progress and see how things are going, that's cool too. So this is funny. That says npm install Waterfront. So basically this broker, which is a very trivial, it's a very trivial library. It uses TJ's Axon library, which is incredible, which is highly inspired by ZeroMQ. These paradigms are not specific to Node or Waterfront or Axon. You could use ZeroMQ to achieve these patterns, or you can use Waterfront is what we use. What Waterfront does is it sets up all of these pairings so that you have these brokers with these channels, and then you can connect to it without juggling in your mind all of the ports, because it just has a convention that does the port mapping for you. So check it out if you get the chance. Check out harp.io if you're interested in hosting on Dropbox. And again, my name is Syntaxy. Thank you.